Now let's solve happy number. A happy number is a process defined by the following process, and let's go through this process together to make sure that it's clear, because understanding the process is integral to solving this problem. So a happy number is a number defined by this process. Starting with any positive integer, replace the number by the sum of square of its digits. Repeat the process until the number equals 1, where it will stay, or it loops endlessly in a cycle which does not include 1. Those numbers for which the process ends in 1 are happy, and we need to return true if n is a happy number and false if not. So let's go through the example to make sure it makes sense. We have a number like 19. What we need to do is we basically need to break down 19 into its two digits, 1 and 9, square each one, add them together. So 1 squared plus 9 squared, that's 82. Then we need to take the 82 and do the same thing, 8 squared plus 2 squared, which is 68. Then we take the 6 and the 8, square each one, sum them together. Then we do the same thing for 100, which is 1 squared plus 0 squared plus 0 squared. And you notice that starting at 19, we kept doing this process until we reached 1. So if we keep following this process, and eventually the sum of the squared digits in our previous sum is equal to 1, we can instantly stop and say that n is a happy number. Otherwise, if we never get 1, then the int n that they gave us is not a happy number. So now you may be asking, if a number is not a happy number and we keep following this process infinitely until we hit 1 but never do, how are we supposed to end this code and return false and return that the int n that they gave us is unhappy? To answer that, let's look at example 2 where n is equal to 2. So I have mapped out the entire process for 2. It starts with 2. We take the sum of the squared digits of 2, which are just 0 and 2. So 0 squared plus 2 squared, that's 4. Same thing with 4. You get 16. Then we take the 1 squared plus the 6 squared, which is 37. Then we take the 3 squared plus the 7 squared, which is 58. 58 then becomes 89. 89 becomes 145. 145 becomes 42. 42 becomes 20. And 20 becomes 4. So why did we stop at 4? That's because if you notice, we've already tracked the 4. We've already seen 4 before, and we've seen where 4 leads to. It leads to 16, 37, 58, so on, until eventually we hit 4 again. So the trick in this problem is not running this code infinitely until we run out of memory or something. The trick in this code is to detect a cycle or to detect a loop. In this case, we started with a 2, 2 becomes a 4. Eventually, if you keep going on this cycle, you're going to hit 4 again. And once you hit 4 again, you're going to go through this cycle again until you hit 4 again. So, like I said, the trick in this problem is detecting a cycle. And so that's exactly how we're going to solve the problem. So how are we going to detect a cycle? We're going to use the set data structure. Why are we using sets? That's because in Java, sets do not store duplicate values. So if I add a 2 to my set, and then I try to add 2 again, we're only going to have one copy of that 2. We're not going to have a set containing 2 and then another 2. And this is important to us because what we're going to do is in our set, we're going to store n, and we're going to go through the process of splitting n into its respective digits and squaring them and summing them together. And then we're going to store that sum again in our set. And we're going to keep doing this process until two things happen. Either we hit a 1 where we can stop and claim that int n is a happy number. And the other case is that we hit a number that already exists in our set, which means we've already seen this number, which means if we keep going, we're going to end up in a cycle, which means finally we can stop and leave the loop and return false. So the first thing we're going to do is we're going to create a set that stores integers. We'll call this scene for all the numbers that we have seen, and this is going to be equal to a new hash set. Now in a while loop, we're going to check two conditions. The first one being while n is not equal to 1, because if n is equal to 1, then we're done here, and n is a happy number. And the second condition that we're going to check is if scene doesn't contain n, or contains n. And what this means is that, like I said, we're going to store n in our hash set, and we're going to follow this process. And each time we find the sum of the squared digits of the number that we're on, we're going to add it to our set. And eventually, if int n is not a happy number, then we're going to stumble upon that number again, but it's already been added to our set. And so if set contains that number, then we can also exit our while loop. So the first thing we're going to do is we're going to add int n to our hash set. Then what we're going to do is we're going to declare an int variable called sum, which is equal to 0. Now this sum is going to be the sum of the squared digits of whatever n is. So now let's go ahead and do the, let's call it happy process. So we're going to loop while n is greater than 0, and we'll see why in just a moment. So in this loop, we're going to create another int variable called digit, which is equal to n modulo 10. So let's say n is a 2-digit number. N modulo 10 will retrieve the second digit in our int n, like 82. 82 modulo 10 is just 2. Then to our int sum, which we created in the first while loop, we're going to add to it digit squared, which is just digit times digit. And then we're going to update our value of n to be equal to n divided by 10. So once again, 82. After we process the 2, after we square it and add it to our sum, we're going to update n to be 82 divided by 2, which is just 8. And then we're going to do the same thing, 8 squared, and add it to sum. And then we're going to divide by 10 again, but then we're going to get 0. And since 0 is not greater than 0, we can exit this while loop. So after we exit this while loop, we need to update n once again to be equal to sum. So we can go back up here and add our sum to our set and reset sum to be equal to 0 and go through this process again. So we're going to keep doing this process until either n is equal to 1, until sum is equal to 1 basically, or until we come across a sum or n which has already been added to a hash set, which means that we're in a cycle. Doesn't mean that we're in a cycle, but if we kept going, we would be in a cycle. So after leaving this while loop, what we need to return is whether n is 1 or n is false. And to do that, we're just going to return is n equal to 1. And n is really going to be the result of one of these conditions. True if n is equal to 1, and false if the number n is already in our hash set. So let's submit our code and see if it works. Awesome. So that was the happy number problem on LeetCode. I hope you found that video helpful, and I hope you understood the happy number problem better, and I hope that I was able to explain it in a well-structured way. And yeah, thanks for watching.